Okay, hello everybody. Welcome to today's lesson for advanced topics in math studies. We're going to talk about 5.6 part 2 notes. We started 5.6 a while ago when we were in school. We did, I think, part 1, just a little bit of it. But we're going to go ahead and pick up go back to 5.6 and revisit this section and talk about in this lesson, the graph of the cosecant of X. All right, so remember CSC is the abbreviation for cosecant. And remember that cosecant is the reciprocal of, do you remember which one? Remember, don't put the cos together. Cosecant does not go with cosine. Cosecant goes with normal sine. So cosecant and sine are reciprocals of each other. So what that means for us is that the cosecant graph is related to the sine graph. So the first thing we're going to do is recall the parent function of the sine graph and then look and see how, since these are reciprocals, we can simply make a few adjustments and come up with the parent function of the cosecant graph. All right, so remember that the sine graph, remember we have our normal 5 increments, 0 pi, and then all the way up to 2 pi, 1 full period. Parent function is a max of 1, minimum of -1. So the sine function starts at the origin, 0, 0, reaches its maximum at the first increment, crosses back down at 0, second increment, pi. Actually, this would be the third increment, really, but next increment, 3 pi over 2 is where it hits its minimum, and then starts coming back up, and at the last increment, 2 pi, 1 full period, it goes back to where it started, like normal, back at 0. And the curve looks something about like that, remember. So there's our sine graph. Now, a couple important parts to this graph we're looking at. The 3 spots where it crosses, or where it's 0. It's 0 here, here, and here. Those are important parts to the cosecant graph. These increments at 0, at pi, and at 2 pi are important. Now, remember that if something is a reciprocal, it means you basically flip the fraction, right? It means you are flipping the fraction. You're kind of flipping it upside down, interchanging the top and the bottom, numerator and denominator, okay? And the cosecant graph is kind of going to do that to the sine graph. We're going to keep things simple. There's a lot more related to it, a lot more in depth, but we're not going to go in depth. We're going to keep things simple and just flip the 2 parts of the graph. There are 2 important parts of this sine curve. This curve here, which is kind of like a hill. This curve here, this part, the second half, kind of like a valley. So those 2 parts are basically going to flip. And then we'll come up with what basically the cosecant graph is. Like I said, there's a lot more involved with X, Y coordinates and stuff like that, but we're not going to go that in depth. So let's finally go ahead and look at the cosecant graph. Now, I said these 3 spots are important, where it crosses or has a value of 0. Here, here, and here. If something has a value of 0, and you flip that fraction, now the 0 is on the bottom, right? And if 0 is on the bottom, that doesn't make sense. It's undefined. And we've gone over this before. On a graph, if something cannot exist or is undefined, we have what we call an asymptote. we had asymptotes on the tangent graph, if you remember, those dotted lines. So we're going to have asymptotes or dotted lines on this cosecant graph too. Because where sine is 0 and we flip it and take the reciprocal, that's where we get asymptotes. So we're going to have asymptotes where we have 0 values, where it crosses on the sine graph. At the first increment, third increment, and fifth increment. Okay? So we're going to have a dotted line at pi, where we have a 0 value where it crosses. And we're going to have a dotted line asymptote at 2 pi, where we have a 0 value where it crosses. You don't need to put a dotted line here because it's your actual axis. So no part of the curve or graph is going to touch or cross these dotted line asymptotes. All right? So you have 3 important asymptotes. You don't really have to draw this one because it's the actual axis. All right? Now, I said there were 2 important parts. This part of the curve, this part of the curve. All you have to do to get the cosecant parent function graph is just flip each of these parts. So look, this point is still going to be at 1 at your first increment pi over 2. And this point is still going to be at -1 at the 3 pi over 2 increment. But if this curve is flipped, it's going to go like this. But it can't hit the asymptotes. So the sine curve that's like this up above, if you flip it, it'll look like this curve. And it goes up forever, cannot hit the asymptotes, so you just put arrows showing that. Second part of the sine curve, we're just going to flip that. So it's going to be a curve opening downward, like a parabola opening downward. All right, so the second part of the sine curve is like this. If we flip it, it's going to be an upside down parabola. And again, arrows like this, going next to the asymptotes, not crossing it. And there you have it. That is what the cosecant graph looks like. It's 2 parabolas, because it's both parts of the sine graph flipped. Arrows, and you don't hit the asymptotes. All right? So we're going to go through 2 examples real quick on the back where we graph some variations of this. Remember, numbers and stuff like that are going to change and move it around, but it's the same properties that we've talked about in other graphs. All right, now, a couple things to remember. Your period or full cycle is still 2 pi. And remember that you have 2 parabolas for all these. Okay, one opening up, one opening down for your cosecant graphs. Okay, and you have to have your asymptotes. All right, so let's go ahead to number 1. We're going to graph each equation, 1 full 2 pi period. All right, so let's look at number 1. We have y equals 2 times the cosecant of x minus 1. All right, now there's 2 things in play here. You have a minus 1 at the end, which causes everything to go down 1. And you have a 2 at the front, which changes your max and min, stretches it out a little bit. So your max and min, which are normally 1 and -1, are going to change to 2 and -2 because of that 2 in front. But these are going to change again because they're both going to go down 1. So your max goes back down to 1, and your minimum drops 1 to -3. Okay? Now, you don't have any movement left or right, because remember, what causes left and right movement is if you add to the x inside the parentheses, which you don't have here. Okay? So now we're ready to go ahead and make our axes. Now we have a max of 1, minimum -3. And we don't have any left and right movement, so we can do our normal increments. Up to 2 pi. Now, since you don't shift left or right, the asymptotes stay the same spots. So you have an asymptote at pi and an asymptote at 2 pi. And you have one curve here between the first 2 asymptotes and one curve here between the second 2 asymptotes. So remember, the max of 1, and guys, this really isn't a max of 1 like we're used to talking about. It's really the minimum for this parabola curve. But, you know, in our mind, those are where points are. So the max of 1 gives us a point here at the first increment. And this curve opens up like we saw on the front side in the parent function. And a minimum at -3 means we have a point here in this increment, -3. And we have the curve opening downward like we saw in the parent function. And there you have it. Graph of number 1, 2 cosecant of x minus 1. All right, let's try one more with some different numbers and different stuff going on. On this one, we have y equals cosecant of quantity x minus pi over 2. And then we're adding 2 at the end. Now remember, inside with the x in parentheses is left and right movement. And remember, it's the opposite of what you'd expect. So you're really moving to the right here. 1 increment. And remember, pi over 2 is 1 increment worth. Add or subtract pi is 2 increments worth. And if you add or subtract 3 pi over 2, that is 3 increments worth. So that's how many increments worth you're shifting left and right based on what you're adding. Okay? All right, and then you also have a +2 at the end, which pushes everything up 2. Shifts it all up 2. All right, so we have our normal max and min at 1 and -1. No number here to change that. But everything's going up 2. So this 1 goes up 2 for a max or a point at 3. And this -1 goes up 2 for a minimum or a point at 1. All right, so we have to make sure we have points at 3 and 1 on our parabolas for our max and min on our parabolas. And everything is shifted to the right 1 increment. All right, so we're ready to go. Now, normally we would do our 5 increments, but everything's going to the right 1, so we need an extra increment over here. So we have pi over 2, pi, 3 pi over 2, 2 pi, and this would be 2.5 pi or 5 pi over 2, whatever you want to put. Now, guys, normally we would have an asymptote on the axis. You don't draw a dotted line, but that's going to the right 1. So that asymptote on the axis actually shifts right here. And this pi asymptote shifts here. Because remember, everything's going to the right 1, and you have to have this 2 pi asymptote shift to the right 1 here. All right, now our max is 3, our min is 1. So 1, 2, 3. All right, your normal curve between the first two asymptotes is still here. A point at 3. And then you can make your curve. And then your second asymptote opens upside down. A point at 1, which would be the maximum for this parabola. It's going to cross the x-axis, that's okay. And there you have it for number 2. You have your 3 asymptotes and you have your max and min points, both curves. All right, guys. That's it for today's lesson 5.6 part 2, graphing the cosecant function. Take care, and I will talk to you guys next time. Bye-bye.